My super chemist out there in King William. This is Tracy Folks, and I wanted to go over the stoichiometry notes we went over today in class. And today we were just starting our notes on stoichiometry, so we had this little handout here. And we were working on the examples on the first page, and then we were also doing some your turn on the back side of that first page. Okay? So the biggie in stoichiometry is you have to balance the equation before you can do any of the fun math stuff. Okay? So here you see I have 2N or 2 nitrogen, and there's 1. So I put a 2 there. Okay? 2 H's, 6 H's. So over here I'm going to put a 3. And I'm looking at this first example right down in the middle of your page. So this paper starts with some history of stoichiometry, which you can read at your leisure, but I won't test you on. But the examples are the really important stuff. Okay? So when I read example 1, it says, if you have 2 moles of nitrogen, I want you to take the numbers and units that you are given, and I want you to write them above the substance in the balanced equation. How many moles of ammonia, moles, can you produce? So all of the examples we're doing today, you're starting with moles and you're finishing with moles, and they're all 2 steps, okay? The first step is always the same. You take what's given, which is this 2 moles of nitrogen, and you put it over 1. And that should seem familiar. Every time we've done conversions, we take what's given, we put it over 1. Okay? Exy poo-poo. One more little line, okay? I don't want to be in this moles of nitrogen. So whatever is up here, I want to get rid of it. And I get rid of those units by putting it in the bottom of the next step. Okay? I want moles of this stuff. So I put that in the top. Now, anytime you have a conversion that's moles over moles, see how this is? You use the numbers in the balanced equation. That's why we had to balance the equation first. So in front of NH3, there's a 2. And in front of N2, there's nothing. And when there's nothing, we just assume that that's a 1. Okay? This cancels out, and I basically end up with 2 times 2, because I multiply across, 4 moles NH3. Okay, that's how easy stoichiometry is. Let's do the second example. Okay? Give me just a minute to write this up here on the board, and then we'll work on it together. So in the second example, this is my equation that's given. As soon as I see the equation, I immediately think to myself, I'm going to balance that. Okay? 2 hydrogens, 2 oxygens, 1 oxygen. So I have to put a 2 there. When I put that 2 there, I now have 4 hydrogens there. Got to have 4 hydrogens there. Alrighty. Reading the example. How many moles of water? All right, above the water here, I want you to put a question mark, moles. That's what we're looking for. Are produced when 5 moles of oxygen. There's my 5 moles of oxygen. I don't even have to read the rest of the sentence. I know that I have 5 moles of this. I want to know how many moles of that I have. Always take what's given and put it over 1. So I have 5 moles of oxygen over 1. Okay? I don't want to be in moles of oxygen. I have to get rid of it. So that goes in the bottom of my next step. I want moles of water. So that goes there. Moles over moles, my numbers always come from the balanced equation. So that's a 2. Oxygen has nothing in front of it, so that becomes a 1. Those cancel. 5 times 2 is 10 moles of water. See how easy stoichiometry is? Not only are you going to be a super chemist, you're going to be a super stoichiometrist. Okay? And we have one more example that I want to do with you. And then you're done listening to me talk. Okay? And that is the third example. All right, so the first thing I do is balance the equation. So there's 3 carbons here. Got to have 3 carbons there. There's 8 hydrogens here. I put that 4 there because 4 times 2 gives me 8 hydrogens there. Now, 2 oxygens here. Oxygens all over the place. 6 there. Plus 4 there means I have 10 oxygens on that side. So to get 10 over here, I put a 5 because 5 times 2 is 10. Now, when I read the example, it's going to look like the other examples. I'm going to be given moles and I'm going to go to moles, okay? So it says how much propane? This is propane. If this were a test or quiz, I would specifically say propane C3H8. I would never expect you to look at this and add that to what you're doing, okay? How much propane is needed to produce 14.2 moles of carbon dioxide? All right, that's how many moles I have. I want to know how many moles of that I need. Take what's given and put it over 1. Now, I don't want to be in moles of CO2. I want to get rid of this. And whatever you're trying to get rid of goes on the bottom of the next step. And what you want, see I want moles of that? That's going to go on the top. Okay? Easy little 2 steps here. Moles over moles, because I am a super stoichiometrist, I know that these numbers come from the balanced equation. All right? That goes away. So I basically end up with 14.2 times 1, which is that. 1 times 3 is 3. Then I put this in my calculator, 14.2 divided by 3, and I end up with 4.7, and these are my little unit poos right here at the end. Moles, propane or moles, C3H8. So this concludes the first set of notes on stoichiometry or our adventures in stoichiometry. I hope it was helpful. I can't wait to see you in class. And if you have any questions, feel free to ask me then. Take care, guys. Toodles, poodles.